What? Is this working? This is true. Thank you. Am I good? Okay, cool. All right, hello everybody. So this was a tool that I've been working on for a bit for Red Team. I deployed this at IRSec, UB. This is kind of like the best thing I've ever written, to be honest. It was pretty fun. So there's a little backstory to it and all that, and I will go into all of it. So starting off, what is NTLM? So NTLM stands for New Technology LAN Manager. So Windows NT, haha. Basically what NTLM is a challenge-based response authentication protocol, which I will explain on the next slide. It's a protocol suite that's deployed on all Windows systems for backwards compatibility purposes. They recommend Kerberos nowadays. It's much more secure. It's sort of the newer thing, and it works better with Active Directory. So NTLM is considered insecure because it uses outdated hashing methods and cryptography. And it's also vulnerable to pass the hash and brute force attacks, which that could be a whole talk if anybody wants to do that. Those are pretty cool. So how does it work? So this is the general process. So the user will send their domain information and username in clear text to the server. I will have a diagram on the next slide too. The server will generate a 16-byte random number. This is called that challenge, and it'll send it to the client. So what the user will do is they'll input their password. It'll get hashed, and it'll generate the NTLM hash of the password. That way, the password is just gone. It's just the hash of the password. You don't have to send it or anything. And then the challenge will be encrypted with the hash that you generated. Then, in order to not send NTLM hashes over the network, you send the encrypted hash instead to the server. So the server got the clear text username. It will retrieve that NTLM hash from the SAM database, which is where the hashes are stored, and encrypt the challenge with the hash. And then it compares the two challenges, the one from the user that you encrypted in step 3 and 4, and compares it to the servers. And if they match, your authentication passes. If it doesn't match, denied. So this is this in a sort of diagram format. So you send your username and password and domain information to the server. It sends back the randomly generated thing. You encrypt the thing, and then pretend the DC is the server in this case, and then it'll pull from the SAM database and everything that's there and checks. So basically, what step are we attacking here? So we are attacking step 5. So when the server gets that clear text username to retrieve the hash from the SAM database, we want to be able to put our hash in there as a backdoor hash before it encrypts the challenge, because it uses the challenges as a way of not sending things over the wire. And oh my God, I said the wire. I did it, yes. So yes, we're attacking this step, and I will go over this. So, doesn't this already exist? Yes. Mimikatz has this functionality already, and it's much better than mine. So this works for Kerberos authentication instead of NTLM authentication, and it works in Active Directory. So basically, it will go to the KDC, which is how AD uses authentication, and then just patch that there. So you can have a skeleton key password. It's just Mimikatz on every Active Directory. It works for all authentication in that respect. I'll get into the limitations of mine later. So, some inspiration for this tool. I didn't pull all of this out of my just head, okay? I'm not that smart. I found this blog post, which was recreating known universal Windows backdoors with Frida, which is a tool I'll go into in a second. So I kind of just followed this blog post along while I was doing this. It was good reversing practice for reversing terrible Windows API calls and disgusting things like that. And I sort of wanted to make something custom made, and then I wanted to write C++ for some reason. I'm not sure why. The link will be there. Yes, you know, it's fun just doing that. And then the link I'll post at the end with the slides. So what is Frida? So Frida is generally made for mobile testing, but you can sort of use it on everything. It's a reversing and testing toolkit. You can inject into process, hook function calls, good for sort of that sort of thing. It generates these handler scripts, which are use a JavaScript API. So I was writing JavaScript for a while too. It's actually not that bad. Despite what JavaScript, normally is. It's usually just, log this return value or something like that, or overwrite this value. The docs are pretty solid. The tool is constantly updated, so they're always fixing bugs, which is awesome. So here's some other authentication background things before I go into some of the blog post stuff. So the authentication handler process is lsas.exe, so that's the process we'll be injecting into. There are two main authentication handler DLLs that I'm messing around with. So the first one is MSV1_0.dll, and the second one is NTLM shared.dll. So the third thing is that an NTLM hash is 16 bytes. That'll come into play later. So this is getting started when I was following the blog post. So there's a thing in Frida that allows you to trace function calls. So you inject into a process, and then if you monitor a certain library, so capital I library or DLL, whatever, or you can monitor certain function calls. You can use regex, whatever you want to do. And basically, it'll auto-generate all those JavaScript handlers for you and pull from that. And then it'll just start logging things. So if you see at the bottom here, I injected into LSAS, and then the first thing that I saw after 11 seconds was this call to LSA AP call package untrusted. So it'll just do the whole call stack of whatever you want to see. So as I was saying, you modify the JavaScript handlers. So as you can see up here, this is just something that I was doing. So on enter, there's these two sections in Frida, on enter and on leave. So on enter is when the function is first called. You can put whatever code you want in there. On leave is sort of what happens after. So literally what I was doing here is just saying, hey, I'm just printing out the arguments, and then on leave, right before it leaves the function, print out the return value. So pretty simple so far. So the first function of interest that I was following was MSV SAM validate. So basically, every time you authenticate with something, you try to log in, you do anything, that sort of thing. It would return a non-zero number if it was an invalid password, and it would return 0 if it's a valid password. So I was like, oh, I'll just return 0 every single time. It's classic, right? I mean, that should let me in. No. Windows does not like you tampering with its authentication. So every time I was doing this, and this was a common issue while I was reversing, the PC would just say, uh-oh, he's messing around, and then restart me. So it was really annoying, but eventually we got things working out. So the next target function was MSVP password validate. This is also in MSV1_0.dll. The blog post ended with allowing all passwords, which is not what I wanted to do. And they were doing return 1 always, and then that would let them in for every password. And then I tried doing that, and it wasn't working. It was the same error, so it just restarted my machine. I was like, okay, great. But I wanted to look more into this function because I had seen some stuff a lot online. There's a whole bunch of other reversing that happened there. So I looked into it a bit more beyond the blog post. So this is after the blog post. I found this function's definition on GitHub. I also found that it was being called from a DLL called NTLM shared.dll instead of the normal MSV one. So as you can see, this is all the parameters that I've taken in this. It just returns a Boolean value. And this one is the interesting one right here. It literally says passwords. We like that. So apparently this is commonly used by hash dumping tools. So, your secret dumps, your Mimikatz, anything like that. Sort of getting the hashes from here. So looking at that, as you can see right here, P user internal 1 information. I looked into that. This led me to this, I searched this on Google and 2 results popped up. And then one was this one. And it had this right here. This is MSDN page, so I don't know why this is public. basically there's another struct, an internal struct, and then it gave me this parameters for this. So as you can see from the first two, you have your NT password and your LM password, 8 bytes each. So the first 16 bytes of this struct is the NTLM hash. Pretty cool. So we found that there. So there's a couple things that we now need to do. So we found the hash. How do we swap it out with the backdoor password? English. So I went to just an NTLM hash generator, chucked my password in that. It would generate this, and then this is what I'll be putting in my code. So next, I needed to find a way to hook function calls. So basically, this is a sort of overview of how this works. I use something called Microsoft Detours. So basically, I will explain with the code later, but high-level overview is every time you hook into a function call that you want, you get a handle on it, and every time that function is called, it will call your function first instead. And then you usually run the original code after that. So I use Detours. I'll explain how it works later. If you want to look at this diagram, it has all the lines and how it actually works, but I'll go over that. And the next two things are things that I had to do in code. So I need to overwrite the 16 bytes of the samper struct with my hash, and I had to make sure that normal authentication worked. This was important. So there are a couple different scenarios here. If one, I hook the function and overwrite it with my hash, no one can log in except for with my password. So that would ruin everything. Two, if I tried to only return a true value for authentication passes, the system gets angry and then restarts on me. So I had to find a way to make normal authentication work, and then as a backup, my password works as well, which I'll go into in a second. So getting into some of the code. So this code was a dynamic linked library that I had to generate. So this is just the general anytime you're generating a DLL, you need this. So basically it's just a switch case. Every time you would attach it to a process, attach to a thread or detach, whatever. All I was doing here was attaching to the LSAS process, so I just had to call my method in there, which I'll show in a second. So basically when you're generating a DLL, I know a lot of 201 folks are going to see a lot of common code here. That's what you have to do for that. So the next thing is getting the handles on the DLL and the method call. So up here, I don't know if people remember load library from 201, but that's basically what this is calling up here. So I'm just loading this library, or actually similar to loading this library. I'm getting a handle on this library, so I'm finding out where this is in the memory. Then down here with this, I have my handle here. I'm getting the process address of this function. So this is the function that we're targeting and we want to hook. So for Microsoft Detours, it's super simple to hook functions. Literally, you begin the transaction, you get the current thread, and then you attach. You have a pointer to the original right here, and then you have a pointer to what you will generate, what you want to call. So it'll attach to that, and every time that is called, it will call my hooked function. And then there's just an error code, and you're committing to the thing down there. So that just says, okay, now do that. So the hooked function, in order for this to be consistent, the hooked function had to have the exact same parameters as the normal function call. So as you can see from earlier, it has all the same as this. I just had to call it my own thing, which was just the hook version. I just named it. Same parameters, same return value, because I want it to be as similar as possible. And when I'm calling this in the detours here as well, all of the parameters that would normally be passed to this function, I want it to pass those parameters to this so that I have them. So this is the code. It's like a for loop. This is the actual backdoor right here, which is pretty awesome. So remember how I was talking about normal authentication right here? So first thing that I do every time my hooked function is called, I call the normal MSVP password validate with all the parameters that it gives me. And if that returns true, that means the user has passed a valid password, and I will return true as well. So normal authentication working. In the case that the password fails, that means they did not pass a valid password. That's when I put my password in. So I have my hash right here. That was the hash I generated earlier. And then in a for loop, I'm overwriting the first 16 bytes of that sampler struct with my password. Then I return the original function call after I've overwritten the memory at that struct with the same function call. So now in this password struct, instead of their NTLM hash, it's my NTLM hash. So it'll call that and then check to see if it's the backdoor password. And then it'll return true if it is the backdoor password. And if it's some other password, doesn't work. Normal authentication. So, demo time. Fun. All right, I'm gonna need participation from the crowd for this one. I need a username and a password.
There's only one, obviously.
Nil is goated. All right, net user. Nil is goated. All right, we'll do nil is. Oh, I'm gonna kill myself while I'm typing this in. Exclamation point. Yes. Oh, yes. Good call. Thank you.
So this works on local users as well.
Local users and domain users. Ah, yeah. I'll go into the limitations in a second. Good call. 72 font. Oh God. That's fine. It's okay. All right, so that's our new user. Okay, I forgot to add it. Okay, so now we run net user. Nil is goated right there. It exists. And I just gotta add it to the admin group quick. Nil is goated. Yeah. Okay, cool. Nice. Okay, so now we have our admin user, nil is goated, with our lovely nil-is-goated exclamation point password. So, say for instance that I am going to WinRM to this box. I don't remember the IP. Oh God, this font size was not a good move. .7. Yeah, oh, it is the same. So we have nil is goated is the user, and then nil is goated exclamation point. So normal WinRM authentication works, correct? We have that. Now let's try my password. Boom. Also works. Yes, thank you. Thank you. And we can try random password as well. It'll just hang forever. So that's that. It works with PSExec as well. Same as the thing. Get into it like that too. So there are some limitations with this. The first thing is that the authentication through RDP, the run as command and logging in from the lock screen is all not possible when this is an Active Directory box because that relies on Kerberos authentication. However, authentication with PSExec, WinRM, WMI is all possible if you use IP addresses when you're sending out your connections. If you're trying to authenticate and you have a host name, it'll rely on Kerberos authentication. So you need to use IP addresses, which is really easy, and I always do that anyway. So that's that. But going back to this, I think that was all my slides. I put a bunch of references up here. The blog post, a quick description on NTLM. This right here, this is that random sampler struct that I found. I found the code for the MSV01 DLL right here. The hash generator I used. If you want to know more about how Detours works, there's a Stack Overflow thing. Here's more undocumented functions. And then this right here was a really cool PDF that I found about, it was written all about the Mimikatz skeleton key malware. And a lot of what I found and based NTLM stuff off was in this magazine right here. So that was good stuff. So thank you very much for listening. Does anybody have any questions? I know that was kind of a lot. Who likes writing C++ code? Grimy.
So Detours was written by Microsoft.
Yep.
For non-malicious people.
Yes.
What's a legitimate use for it?
Okay, a lot of it is probably used for, testing, and, you have a lot of black box processes that you might be trying to debug and find, function calls to and that sort of thing. The issue is it's so easy to use. So I'm just like, oh, okay, I'll just use that. And it worked unbelievably well. So that's just Detours. So yeah, Detours is open source. It's pretty well documented as well.
You just have to install the DLL and then inject it.
Yeah, it's practically that's it. Oh yeah, I didn't even talk about how it.
Yeah.
Let me go back to the.
Deployment or talk about that?
Let me. Yeah, I didn't even. I was supposed to show this in the demo too. Oops.
I got it.
So basically, this DLL is injected into the LSAS process that I mentioned earlier. Let me find Process Explorer. And this will show us. So if we pop down to LSAS, you guys are probably not going to be able to read this. Can I make this bigger? I don't know if I can make this bigger, but basically, LSAS right there. You can see that my Nosferatu.dll is injected into this process. Yeah, simple as that. Yes. Yep. So authentication is handled with LSAS. So no matter what. Yeah. My throat's getting kind of dry, so that's why I'm stopping. Okay. Any other questions?
Enzo coughing fit when.
Ah, that's happened before.
Enzo next tool when.
Yes.
Does this go around Defender?
No. So if you're injecting into the authentication process, Defender does not like that at all. So you got to turn it off first. Sorry, Chief. Any other questions? Yeah, we've got ways. Okay, thank you guys very much. I appreciate it.
All right. Thanks, Enzo, for an amazing presentation. Pretty cool stuff.
Thank you.
All right, and next up we have Skylar with Honey Pods. Give a round of applause. Yep. Yeah, is that right? Yep. Okay, awesome.
Do you now?
Okay. Where is your screen? It's up there. Oh, where'd it go? It's not up on the stream.
Oh, I shared it on Zoom.
Uh-oh.
You have to pick.
Yo, hold on.
Whoa,
Wait, Enzo, real quick. Enzo.
Yes.
It's not